Physics 2211, Lab 3. In this lab, the objective is to calculate the mass of a black hole by analyzing a star's motion to find the net force on the star from the points in the dataset. Some of the key physics principles that we are going to use are Newton's law of gravitation. F net equals the gravitational force times the mass of the star, then the mass of the black hole divided by the magnitude of the radius squared. We will also be using Newton's second law. F net equals dp over t, or the net force equals the rate of change of momentum. And also F net equals Fg, or the force acting on the hole is Fg. The parallel and perpendicular components of the force, or dp dt equals dp dt parallel plus dp dt perpendicular. And finally, F net equals F parallel plus F perpendicular. Some of the givens in the lab are: the black hole is not moving because it is much larger than the star. The black hole is also located at the origin. The mass of the star is 2.0 times 10 to the 30 kilograms. The star's trajectory is given by a unique trajectory sent to my email. One day is 86,400 seconds, and the net force is equal to F times G. Here is the GlowScript code for the lab. As you can see, setting some of the variables, changing the force, and all of the different components of it. Now here's the model of the star revolving around the black hole. And you can see the perpendicular and the parallel forces and the change of momentum. And then analysis questions. How does the net force and its parallel and perpendicular components differ from the rate of change of momentum in its parallel and perpendicular components? The net force is more of a causation of the change in momentum, so the momentum will continue to change as long as there is a net force acting upon it. And this is true in both the parallel and perpendicular components of both of these. And then the next analysis question is: imagine that the black hole whose mass you found was removed and a different black hole was placed in the same location. Assume the motion of the observed star remains unchanged and is affected only by the gravitational force of the black hole. Could you tell the difference? In other words, is it possible for you to find a value for the mass of the new black hole that is different from the mass you found of the original one? The answer to this question is no, because we know that if the force would change if the mass of the black hole, the new black hole, was different, and so the trajectory would then be different, and everything about it would be different.